exactly नहीं determine कर सकते. If I find out the position properly, then there will be a large difference in my linear momentum, and if I find out the linear momentum, then there may be a large uncertainty in the position. Now if I want two of my waves to be in phase, if I want two of my waves to be in phase, then in that case what do we have? Say first understand, if I want some kind of a pattern, I expect my waves to be in phase with one another. That means two waves are said to be in phase when the crest of one corresponds with the crest of one and the trough coincides with the trough of the other. That means these should be overlapping. This wave number 1 and wave number 2, when you put on one on top of the other, they should exactly overlap. So then I would say that the two waves are in phase. You will be doing it in physics also. So in this case we have done it. So now in this case you will say that when the crest overlaps with the crest and the trough overlaps with the trough, crest trough overlaps with one another, then the two waves are said to be in phase. Okay, and when you have the crest of one and the trough of the other, then it's like then it is said to be out of phase. Now here, if I want to talk about say being in phase, let me just take an example from your group only. If say supposedly she starts running on a circular pathway, okay, and I start follow to run after her, I follow. So will I be in phase or out of phase? I repeat, it will be either in phase or it will be out of phase. I am saying she starts running on a circular pathway, okay. When she is halfway through, I start running after her. So that is not in phase. In phase means that I have to run along with her. And if I want to run along with her so that our speed and steps match, then I will have to wait for her to come till the starting point. So then that means when she will cover one complete path and then I will join her for the second path, then in that case I will say that I am in phase with her. You getting the point? To be in phase doesn't mean that you are following the same path. See, the nature of the waves in these two cases is also this. One is like this in the second case that I have taken, and the other is like this. So kind of the behavior is just the same, but it has started following it up late from maybe this point. So they are kind of out of phase. You getting the point? So they are out of phase where the crest is overlapping with the trough of the other wave. So that is out of phase. Clear with that? So that means if both of us are in phase with one another, what will be the difference in path? If she has taken one round of 2 pi r and I now take the second round of 2 pi r. So what is the difference in our path? 2 pi r, because now she will take 2 into 2 pi r, 3 into 2 pi r, but I joined her in the second round itself. So what will be the difference? It will be 2 pi r. So that means whatever is the difference between our path, it should be an integral multiple of wavelength. थोड़ा समझ में आया? Say a yes. Nod your heads. Exercise. So here what we have is, say if now we have to talk about the waves of the electrons to be in phase with one another, then I can say that my path difference, which may be 2 pi r, my path difference which is 2 pi r, that will be equal to n into lambda. Do you understand that? Path difference has to be an integral multiple of wavelength. For my two waves to be in phase, this anyways you will be using this concept elsewhere also. If I want two of my waves to be in phase, then the path difference between the two waves should be equal to an integral multiple of wavelength. An integral multiple of wavelength. And here let me just put an n dash. Why? Because we had been referring to n as the orbit number 1, 2, 3, 4 and so on. But here this n dash would refer to, say if my wave starts from here, this is 1. Then if the second wave starts from here, this is now the second, the number of waves you getting. So here this n dash stands for the number of waves or the number of path lengths that are covered by the wave. N dash is the number of waves made by the electron. You can just note down, this is the number of waves made by an electron in the Bohr orbit, Clear what the meaning of in phase? That means if the second some other electron has to be in phase, it will have to wait at one point and then move along. So moving along is like to be in phase. Okay, then here we know that this n dash is equal to then 2 pi r upon lambda, and you know that your lambda is equal to h upon mv. What principle have I applied? De Broglie's principle. And then if I am writing my n dash as 2 pi r, I can take this mv above upon h. What is this mvr equal to?
Angular momentum.
This is equal to 2 pi by h into L, which is the angular momentum. And according to Bohr's principle, your angular momentum is quantized. What is L equal to? mvr is equal to nh upon 2 pi. That n is your orbit number. So you have 2 pi h upon, what is that? mvr is equal to nh upon 2 pi. So this becomes equal to n. ठीक है, अब इस कॉन्सेप्ट को एक बार क्लियरली समझो. पहले मैंने समझाया what do you understand by two electrons to be in phase with one another. That is like if the electron covers one particular pathway, the other will have to wait till the starting point to join it, and then the difference there between their path should be an integral multiple of their wavelength. Okay, and that can be represented as 2 pi r is equal to, that means my total circumference, this total circumference, what is that? 2 pi r, that is equal to some number of waves which are covered. So n dash into lambda, this is clear? Say yes strongly.
Yes, ma'am.
2 pi r is equal to n dash into lambda. Clear? Now n dash is the number of waves we've seen. So from here, from this formula itself, n dash is equal to 2 pi r upon lambda. What is my lambda? It is h upon mv, de Broglie's principle. Lambda is equal to h upon mv. When I take this mv above, it gives me mvr. Now I am just substituting that mvr by nh upon 2 pi, because mvr is equal to nh upon 2 pi is one of the postulate of the Bohr's model. So we have mvr is equal to nh upon 2 pi. And now if when I cancel this h and this h goes to 2 pi pi. So what am I left with? N. And what was this n? It was the number of the orbit. First orbit, second orbit, third orbit. So what does this indicate? I started from the number of waves made by the electron in one orbit, and I reached that number of waves is equal to the number of the orbit. So that means for the first orbit there will be one wave. For the second orbit there will be two waves. Why? Because the number of waves made by an electron in one orbit will be equal to the number of that orbit. ये चीज समझ में आ गई? अगर मैं डायरेक्टली बोलती तो शायद नहीं आती. But now you know that this is kind of an application of de Broglie's principle also. That from the de Broglie's principle I get to know that the number of waves which are made in one orbit is equal to the number of that orbit. If it is first orbit, how many waves? 1. If it is second orbit, 2. Third orbit, 3. I give you a question verbally. Find out the number of waves made by a Bohr electron. Bohr electron means all the postulates should flash. Okay. In one complete revolution, In the third orbit? 3. Very good. It should be a spontaneous, a little more. Even before the question should have been put. Okay. Then we have, after this, we can also, then we started talking about, okay, this is what we are talking about. The number of waves made by an electron now we have talked about. Yes? L is our angular momentum. Let me tell you, the general notation for angular momentum is generally written as L. L is equal to NH upon 2 pi. Why? Because MVR, which is L, is equal to NH upon 2 pi. What is this? The quantization of the angular momentum according to Bohr's model. Okay, then here we have a question that I discussed that question with you. I didn't know that I'd put it here. That you can find out the number of waves made. What about now in the fifth orbit? Now that the question 5. Okay, calculate the uncertainty in position, assuming the uncertainty in momentum is equal to 0.1%. For first, the tennis ball is a macroscopic entity. So you can straight away start to calculate for a tennis ball weighing 0.2 kilograms, and moving with a velocity of 10 meters per second. So you can quickly calculate it. What is the principle that you are using here? Uncertainty bolte hai, you should immediately remember that we are talking about Heisenberg's principle. So here the formula that will be used will be delta x into delta p is greater than or equal to h upon 4 pi. So here you can just take it to be equal to 4 pi to calculate. Delta x into delta p is equal to h upon 4 pi. 4 pi, alright. And then we have our p to be equal to mass into velocity, that's linear momentum. So that is 0.2 kg into 10 meter per second. That will give me 2.0 kilogram meter per second. That will be my linear momentum. Delta P is given to be equal to 0.1% of P. So then that means that becomes equal to 1 upon 1000. So that becomes equal to 10 to the power minus 3. 0.1% means 0.1 upon 100 into the value that I have just derived. And then we'll have delta x from here to be equal to h upon 4 pi delta p. What is my h? That is 6.626 into 10 to the power minus 34. What is my pi? That is 3.14, and the value that I have calculated for delta p is 2 into 10 to the power minus 3. So quickly calculate it. 3 2s are 6, so you can just roughly calculate. It becomes almost equal to 1 upon 4, and that is equal to, say, somewhere around 2 point, that's like 3.2, so that will get cancelled. So around 2.56 something. Do you get it? What is the quick way of cancelling? It is 6.626. You can see a 3.14 into 2, so that will be roughly equal to 6 point something. So it will be roughly equal to 1 by 4. So rough calculations can be done mentally. So the more you practice, the more you will get the hang of such calculations. So here you will have the answer as 2.6 into 10 to the power minus 32 meters. So here you find out, and let's check it out for the second question also quickly. For the second part of it, it talks about the uncertainty in momentum is given as 0.1%. An electron moving with the velocity. So again you know the mass, 9.1 into 10 power minus 31. You know the velocity, that is 2 into 10 power 6. So just calculate the linear momentum. Now this is for the electron. This was for the tennis ball, and now I am checking it out for the electron. So let me just find out the linear momentum for the electron. That will be 9 point mass into velocity. Mass is 9.1 into 10 to the power minus 31. Velocity is 2 into 10 to the power 6 meter per second. Alright, and that will be equal to somewhere around 1.82 into 10 to 1.82 into 10 to the power minus 24 kilogram meter per second. Very nice. And then you have delta P is 0.1% of that, 0.1% of P. Then that means that will be, you add 10 to the power minus 3 to it. So then you will have, that will be equal to 1.82 into 10 to the power minus 27 now, kilogram meter per second. Clear for that? And then again calculate, follow the same pathway. Delta x will be equal to h upon 4 pi delta p, which will be equal to, again I am not putting the values now, 6.626 into 10 to the power minus 34 upon, you will have 4 into 3.14 into 1.82, which is again kind of equal to 2, and here you will have into 10 to the power minus 3. So the answer will again turn out to be somewhere equal to 2.8 into 10 to the power minus 8 meters. Okay, this example is even important from your subjective paper point of view, because Heisenberg's uncertainty principle is like important. So if you know the uncertainty in momentum and not the uncertainty in position, you can easily find it out. So now just look up. This was the case for a tennis ball. Okay, the tennis ball was moving with a speed of 10 meter per second, and the electron is moving at almost 10 to the power 6 times, almost 10 to the power 6 times that speed. So that means which is moving faster, tennis ball or electron? Electron is moving faster. Then here in this case, when I check up the uncertainty for a tennis ball, it is 2.6 into 10 to the power minus 32. That means 0.0000, and you go on till almost 30, and then you put a 26. So the value of the uncertainty in position is very, very, very less. You getting the point? This value is so small, then that it means that the moment I find out the linear momentum, I found the linear momentum mil gaya, then after that I wanted the uncertainty in position. Now when I find out the uncertainty in position, that uncertainty in position is so small that's almost negligible. So then that means I can find out my position also and my momentum also simultaneously and precisely, I mean exactly, almost there. Why? Because the difference in the value that I calculate and the value that actually exists will be having a very small order, that is 10 to the power minus 32. Now when I move on to the electron, which is moving at such a fast pace, at such a fast velocity, there I calculate my delta P and hence delta X, that is equal to 2.8 into 10 to the power minus 8 meters. Now which number is larger, this or this? This. Why? Because 10 to the power minus 8 means 0.0006 times you put zeros, and then you have your, 7 times you put zeros, and then you have 28. Okay. So then that means this value is kind of comparable, and therefore the uncertainty in position will be large. That means it changes its position. The moment you calculate its linear momentum, it changes its position, or vice versa. If you calculate the position, then the linear momentum would change. Clear with that? So this was just example to just talk about the Heisenberg's uncertainty principle. The next thing that we have is we started talking about quantum mechanics, and to help you remind as to what quantum mechanics is, I started talking about it right at the beginning of this class. Macro means classical, micro means quantum, and you don't have to forget macro means that the energy levels are just one on top of the other such that there is a continuous form of energy. And in case of quantum, you have discrete energy levels, that is jumping of electron. That is the basic difference. If you keep that thing clear, then you like a master in it. And what is the storehouse of information that you get? What explains the nature of any microscopic entity is your? If all of you all are known by your names, what is our electron known by? By a wave function. Repeat it again. I told you last time that just as all the macroscopic particles have an identity, this is a chair, So you write it as CHAIR. This is a table, TABLE. You have your names. So the moment you have to specify a macroscopic object, you have a name to explain it. But for electrons or microscopic particles, each electron will have its own wave function. Okay, and that wave function may be real or imaginary. Write it down. The wave function of an electron, the wave function of an electron may be real or imaginary. The wave function of an electron can be real or imaginary. Now, so that is why your wave function has no physical significance. Your wave function will have no physical significance. Physical significance means that supposedly you imagine that you cleared the IIT exam. Okay? You all imagine that you cleared the IIT exam and keep sleeping and enjoying your life for another 2 years. Will you actually get through? No. Imagination hai, karte raho. I mean, imagination has no physical significance. You get the point? That anything which is imaginary has no physical significance until and unless you get it to the real world. So if you have to actually, you dream about it, I have no problems. But you need to put in a lot of work also along with it. So now coming back to wave function. Wave function can be real or imaginary, because I am studying a microscopic particle, it may or may not be there. But unless and until I am sure that the particle is there, what is the point of studying it? So what I do is, in order to attach a physical significance to it, now in order to attach a physical significance to your dream, what will you do? You will combine it by studying. There is a difference of sleeping and dreaming or daydreaming. Maybe some of you are like sitting with open eyes and dreaming about something. So what you can do is, you can actually attach a physical significance to it by studying. So now here for wave function, which has no physical significance, you know about imaginary numbers a little? Say supposedly the wave function is equal to a plus iota b. This iota is an imaginary number where you know that I square is equal to minus 1. Very good. So you know that this is an imaginary. Now again, if it is imaginary means it has no physical significance. So here, if I have to attach a physical significance, I will always multiply my wave function with its complex conjugate. I will always multiply my wave function with the complex conjugate. And what will that be? I have my wave function as a plus iota b. Complex conjugate will be minus part of that. So if you've done it, it will be a minus iota b. What is a plus b into a minus b? It is a square minus b square. So minus of I square b square, I square will be minus 1, so it becomes plus. So now does it have any imaginary part? So always your wave function is written along with psi star. So one extra thing that I didn't tell you last time was this, that each of the electron is known by its own wave function. Now although electrons are indistinguishable, although you all are studying in 12th standard, but each one of you has a separate identity. So although all the electrons are indistinguishable, each of the electron will have its own wave function, but it can be real or imaginary. So when we talk about real or imaginary wave function, then we cannot attach any physical significance to it. How can we attach physical significance? By making it real. And how do you make it? By taking the complex conjugate and multiplying it with it. So whenever we take a wave function, I have taken a very simple example. Normally when you will study it in details in higher levels, then you will remember me at that time. So if you have understood, I will feel proud of you. So you have wave function which may be real or imaginary. So no physical significance. Wave function star means complex conjugate, so it has real significance. Another thing that I told you was that it should be well behaved. What were the conditions? Louder.
S, C, F, D, and D.
We met last week only, right? Please keep oiling your mind. It has got rusted a little. How will you do it? What is it? SCF, BND. Single valued, continuous, finite, must satisfy boundary conditions, normalizable, doubly differentiable. I did it last time, I'm not doing it again. There is another expression around which your quantum mechanics revolves, and that is your Schrodinger wave equation. Schrodinger wave equation, which is nothing but H operator psi is equal to E psi. Remember that this equation can be exactly solved for only one electron systems. Write it down, that this equation can be exactly solved for hydrogen atoms and similar systems. What will be the similar systems? He plus, Li2 plus, Be 3 plus. You remember the first 20 elements?
Yes, ma'am.
We're not going to that, but and so on. So whatever system has only one electron, it can be exactly solved for that. What about the others? It can be solved by approximations. Then it loses its identity. If I put some approximations in it, then it loses its identity because now it is no more original. What is normalizability is a doubt. Okay, now I'll just explain. Say I am studying an electron in a box. Okay, all of you here, just listen to the story I am telling. Not exactly a story. There is an electron which is there in a box. Okay, nod your head. Now it has a wave function. So that means I cannot attach any physical significance to it. If I am studying that electron in a box and if it is not there, then what is the point of studying it? You getting the point? So I have to make sure that the electron exists within the box, right? If I have to talk about an electron, I have to make sure that the electron exists in the box. It is just analogous to, like all of you all are sitting in this classroom. If none of you are listening to me from there and none of you are sitting here and I keep on teaching and teaching, is there any point teaching? No? Then what will I have to make sure? That none of you move out of this room and you keep sticking to where you are. That is called normalizability. It is to make sure that your particle exists within the domain of the system considered. I repeat, normalizability means, that's a question, I didn't talk about normalizability, but because it came up as a doubt, normalizability means that there is a definite probability of finding the particle, within the domain of the system considered. I'll first repeat the same concept. I am still explaining normalizability. See, normalizability means that there is a definite probability of finding the particle within the domain of the system. ये चीज समझ में आई? That means I will make sure that the particle exists within this box. So if you all are running, I'll catch hold of one student, get that student back to this place and make sure that student sits for the class throughout. So that is like making. So what am I doing? I am normalizing the class. So I am normalizing the system. I'll feel normal then, right? You here with me, all of you all? So now what we are talking about is, so if I have no physical significance attached to my psi, this all of you all have understood? Now if I multiply it with its complex conjugate, I will have a definite physical significance. That will give me the probability density. This psi star is known as the probability density, which implies that probability density means it will talk about the it will give me an idea about the space in which the electron may be existing. It will talk about the probability of the space in which it will talk about the space in which there is maximum probability of finding the electron. Okay, like if there is like this much space, so it will talk about the probability of finding the electron in this region. Say I supposedly put a spherical shell here. So psi star will tell me what is the probability of finding the electron in that region. That means what is the probability?
For different regions, there is different
Probabilities. Like for example, we'll just take it up. Now here what we have is, we have the probability density. Probability density matlab we'll get to know what is the probability of finding the electron in a particular region. So if it is very very high, that means the electron is 100, matlab almost nearly 90% there. And if it is very very low, that means the electron may not be present there. It may be present elsewhere, but slowly steadily coming here sometimes. So normalizability means that the probability density of finding that microscopic particle will be equal to 1, means 100%. That means there is a definite probability of finding the particle within the box. So this is the condition of normalizability. There's a doubt? In the entire region, d tau means, okay, I'll just put it. No, this tau is not the torque. This tau is the volume element. So if I am talking about 3 directions, x, y, z, volume element. Alright, what are the 3 dimensions in space? We have the x, we have the y, and we have the z. Right, all 3 are mutually perpendicular to one another. तो अगर electron found होगा तो इन्हीं 3 directions में से you will find it somewhere. If the electron is present, तो इन्हीं 3 directions में कहीं ना कहीं होगा ना. And if I want to make sure that the electron exists, the probability density psi star in that region found in completeness should be equal to 1. So understand it only qualitatively, that there is a definite probability of finding the particle within the region. समझ आया? उसके बाद अब क्योंकि somebody asked this question of normalization, let me talk about one more concept. If you can grasp it easily, very good. You may get a high score if it comes in the IIT also. That is the principle of orthogonality. This is what, when normalization means I am making sure that there is a definite probability. Orthogonality means that when I have psi into psi star into d tau at one level and another level, then that will be equal to 0. ठीक है? Remember that when psi star is equal to 1, it's normalizability. When psi m into psi n star is equal to 0, then it is orthogonality. I'll explain the meaning. What is the probability of you means each one of you, of being present here in the class and outside the class simultaneously? What is the probability?
0.
Right here and right outside at the same time. It will be 0. Either you can be present here or you can be present outside. So similarly, orthogonality is, what is the probability of finding the electron in level m and level n at the same time?
0.
So that's orthogonality. समझ आया तो ठीक, नहीं तो कोई बात नहीं. Okay. So now there was a question again, a doubt. What is this SCF VND? You tell me. Single valued. Wave function should have only a single value. What is this C? Louder so that the mic hears you. Continuous. So that means the wave function, whatever you have, should be continuous. It should not be in breaks, that you get one curve here, another one here. What is this? Finite. It should be finite. Very good. It should
Satisfy
boundary conditions. Thank you. It satisfies boundary conditions means it should remain a particular boundary. It should be normalizable. And I just explained. Normalizable matlab it should be present in the system. And that means psi into psi star, the probability density should be equal to 1. And then that is the 100% probability of finding the particle in the system. Then it should be doubly differentiable. Differentiation d by dx you should be able to do, and d square by dx square also you should be able to do. Okay. So SCF, B and D. Single valued, continuous, finite, must satisfy boundary conditions, normalizable and doubly differentiable. Clear? What is orthogonality? Orthogonality means what is the probability of you being found wherever you are sitting and at your home simultaneously. आप यहाँ पे भी present हो और घर पे भी present हो एक ही time पे, ऐसा हो सकता है? नहीं. So what is the probability? 0. So what is the probability that you find the electron at one level m and another level n at the same time? It will be 0. So normalization means at the same level 100%, but at two different levels 0. Okay? Any other doubt? No. No? Okay, then we have just checked it up that Schrodinger wave equation can be exactly solved for single electronic systems, and remember for multi-electronic systems फिर से problem हो गया. But what we do these days is we modify, put some approximations to the Schrodinger wave equation, and then we can try to solve it. Okay? It can be solved by putting approximations just in case if a question comes. But remember, it cannot be exactly solved for multi-electronic systems. Okay? Then from the solution we get the energy, and let me tell you that the energy that we get for the Bohr's model is the same that we get from the quantum model. So energies are the same. See, this is the only concept that must be new to you. So please go through this particular part of the board once again. Do you want me to write it again?
No, ma'am.
So we have talked about the Schrodinger wave equation. Can you just repeat the Schrodinger wave equation for me? H operator psi is equal to E psi. Okay, and it can be solved only for best example, hydrogen atom. When we solve it for the hydrogen atom, we see that we get 3 quantum numbers from the solution. We get 3 quantum numbers that I had quickly gone through last time. Those 3 quantum numbers are n, l, n is the principal quantum number. It tells you information, it gives you information about the energy. It gives you information about the energy, and n is basically the level that we talk about, right? Whichever level, it's the principal quantum number. So the first level, the second level, and then there are sub parts of this n only. So it can take up the values going from 1, 2 and so on. It's the first level, the second level. So naturally I am talking about the first, second, third level. So it starts from 1 and not 0. 0 means no level. Or sometimes 0 is referred to as the lowest level or the ground state level. Okay? For the ones who have come late, we have Schrodinger wave equation. And when we solve Schrodinger wave equation, what is the equation? H operator psi is equal to E psi. Clear? What is it? Say it aloud. H operator psi is equal to E psi. And what are the solutions of the 3 quantum? What is the information that we get from the solution? We get 3 quantum numbers. What are those 3 quantum numbers? N, L, M. Principal quantum number, azimuthal or angular momentum quantum number, and magnetic quantum number. Clear? So here what we have is, we have the first, second, third, fourth and fifth level and so on, and then we have the angular momentum quantum number, which can take up the values from 0 to n minus 1. So it can take up the values from 0 to n minus 1. So this implies that when my n is equal to 1, then my L will be equal to 0. When my n is equal to 2, my L will be equal to 0 and 1. When my n is equal to 3, L will be equal to 0, 1, 2. And remember that each of them represents a subshell. You have a principal shell, and then it is like a division of that. Now it will be 1, and let me just tell you this 0, when L is equal to 0, it stands for the S shell. When it is equal to 1, it stands for P. When it is equal to 2, it stands for D. and when it is equal to 3 it stands for F. Okay, these are the various shells which actually exist within any principal level that we talk about. So we have when n is equal to 2, it will be now, so this will be a representation of 1s, this will be 2s and 2p, this will be 3s, 3p, 3d and so on. You can just find it out. Okay, clear with that? One important factor that I wanted to tell you here is that your orbital angular momentum, you know the L values, right? Your L values will be known if you know n. So your orbital angular momentum is represented by under root of L into L plus 1 into h upon 2 pi. The orbital angular momentum which is associated with an electron in a subshell. The orbital angular momentum which is associated with an electron in a subshell is equal to under root of L into L plus 1 associated with an electron. It is the angular momentum associated with an electron, and in many of the books you will find that this h upon 2 pi is also represented by an h cross. This h cross, wherever you see an h and a cross, it means it is h upon 2 pi. Please, because in these expressions are like very common, so you should know h cross means it is h upon 2 pi. And it is also known as the reduced Planck's constant. H is the Planck's constant, h upon 2 pi is used so many a time, so h cross is known as the reduced Planck's constant. Why reduced? Because whenever you put anything in the denominator means you are dividing it, so reduced. Yes.
I talked about 7p, then how we found out the quantum numbers of 7p?
When we go to the 7th pth level, we won't go to that higher number, but that means n is equal to 7. The principal shell will always be the one which is represented in the coefficient, the very first number. So if you are saying 7p, then that means n is equal to 7 and L is equal to 1. So any word or question and you can just relate it. P means L is equal to 1. Okay. Then we talk about the magnetic quantum number, and in magnetic quantum number what we have is you have the values going from minus L to 0 to plus L, and it gives us information about the orientation. Now this gives us information about the orientation of the orbital with respect to the coordinate axis. Orientation means, I will just explain, that in which direction is our orbital existing. So what we have is, it goes from minus L to 0 to plus L. So if we talk about here itself, when n was equal to 1 and L was equal to 0, we had the 1s level. So here m will be equal to, m goes from minus L to 0 to plus L. So here m will also be equal to 0. L 0 है ना, तो minus 0 भी 0 है, plus 0 भी 0 है और 0 भी 0 है. A weird concept of talking about minus and plus, sorry to all the mathematicians. So here we have an n is equal to 2 and L is equal to 0, so now here m will be equal to just 0. So that means S has only one, nothing, no divisions further. S exists as only one orbital. Okay, and when we talk about P, here m will be equal to, now L is equal to 1. So now it will be minus 1, 0 and plus 1. Is it visible? Minus 1, 0 and plus 1. So here, then that means my p orbitals has further divisions into 3 parts, and that will be according to the coordinate axis. What are the 3 coordinate axes that we have? X, Y and Z. So here the 3 levels of p that we have further, that we get to know from the orientation. The magnetic quantum number. So we'll have a px here, py and pz. Normally I tell you z is taken to be the internuclear axis, px, py. Px and py, say you have a table in front of you. Let the x axis go like this and the y go like this on the plane of the table itself, and the z, let it be mutually perpendicular to it, standing erect. So you have x and y on the plane of the table, x on the table, y on the table, 2D में जैसे बनाते हो पेपर पे, and z is right above the table. Got it? So this z at times is considered to be the internuclear axis. Internuclear axis मतलब मेरा molecule अगर है तो उसके बीच में जो bond बन रहा है ना, that is about this z axis. That means my bond is about which axis? Z axis. Generally taken. In some of the books you will find this axis to be x, so just get it accordingly. Otherwise all these three are degenerate. What is the meaning of degenerate? It means that existence of several energy states at the same energy level. That means if I talk about my S level, I will say that this is my S. Okay. If I talk about now my P has now 3 divisions. So it will be Px, Py and Pz, and all 3 of them will have the same energy. Okay. Then here again you can find it out. When n is equal to 3, L is equal to 0. So what will be the value of m? Tell me. 0. So that means 3 has no subdivisions. Then you have, for this case, m will be equal to again minus 1, 0 and plus 1. So we have 3px, 3py and 3pz. And then when we talk about d, it is 2. So you will have m to be equal to minus 2, minus 1, 0, plus 1, plus 2. Right? Now here, when I am talking about, I am rubbing it off. Remember that only 3 quantum numbers are known from the solution of Schrodinger wave equation. Now here, when I have m, what was the case I had taken? When n is equal to 3. When n is equal to 3, my L will be equal to 0, 1, 2. And m in this case will be from minus L to plus L. So it will be 0 here. It will be minus 1, 0, plus 1. And for this case, it will be m is equal to minus 2, minus 1, 0, plus 1, plus 2. Alright. Now for P we said 3 states are available. Now further divisions, Px, Py and Pz. D, that means has 5 degenerate states. What are those 5 degenerate states? They are dz square, you have dx square minus y square, you have dxy, dyz and dzx. Alright, and all these are obtained quantum mechanically through very complicated expressions that will make you get confused at this level. So remember that. Now there is another, please tell the significance of it means significance of what? Please specify, there is a doubt. Please explain the significance of it. If you want the significance of m, L and n that we are talking about, then your n is the principal quantum number that tells you about the energy and the main shell. Then you have L, which is the angular momentum quantum number, alright, or the azimuthal quantum number. Then you have the magnetic quantum number that talks about the magnetic character as well as the orientation of the orbital. Right? So remember that here we have 5 degenerate orbitals. Then we come on to, yes? Here, no. They are actually degenerate. At your level, I can just tell you, because many times that I found that question a little weird, that what is your, it was given, I am giving you a question that was given in the entrance examination. The question was, you have to specify the level. Where n is equal to 3, m is equal to 2 and, L is equal to 2 and n is, what is there, m is equal to, n, L and m values were given as 3, 2 and 0. So what does it mean? 3 means the third main important level, then 2 means 0, 1, 2, S, P, D. So this means D, and 0 was asked. So 0 can be either of the 5 as per your knowledge presently. 0 can be any of the 5. It can be dxy, yz, zx, x square minus y square or z square. So now here in particular for 0 it is dz square. So that was like asked in the question. So I just wrote it accordingly. So you can just take 0 1, you can remember corresponds to dz square. Otherwise, what is m and n? Now the question has become more clear. This is a concept that we just did when we just finished up the quantum page. You remember normalization was when you are finding out the probability of you being present at the same level. When you are present here. So that means normalization was psi at say mth level, whichever level, and the complex conjugate also at the same level. That means what is the probability of you being found at the same level, and that we said was equal to 1. What was this principle? What was this principle? Normalization. Louder.
Normalization.
Now when I am saying that I am talking about you being present here in this room and you being present outside of that room at your home or somewhere else at the same point, what is the probability?
0.
It is 0. That means if I talk about one level as m and another level as n, then what is the probability in that case? 0. And when I take all the 3 dimensions, I can put it as d tau. That is the volume element over the entire space. Sometimes put like this also. Over the entire space. So what is the probability of finding the particle at the electron at the m level and n level simultaneously at the same point? An electron cannot be present at one level and the other level at the same point. So that is equal to 0. So m and n refer to 2 different levels. It may be 1 and 2, it may be 2 and 3, it can be any number. Clear? So that was our orthogonality principle, where that m and n had nothing to do with this m and n. That n and m refer to different levels. Okay, here your m is your magnetic quantum number and your n is your principal quantum number, which you have obtained from Schrödinger wave equation solution. Okay, then remember that the number of subshells is always equal to 2l plus 1. For that is why when L is 0, you have only 1. That means for S, you have only one shell. When L is 1, when your L is 1, then it is 2 into 1 plus 1, that is 3. So that is why P has 3 subshells, Px, Py, Pz. When your L is now 2, your D will have 5. So that will be equal to 2 into 2 plus 1, that's 5. So that is why you have 5. And similarly, if you find it out for F, there will be 7. Now the fourth, there are actually 4 quantum numbers. Okay, the first 3 are obtained quantum mechanically. The fourth one, which is asked in the examination also, is the spin quantum number S, small s. That spin quantum number was discovered experimentally. There were 2 scientists, Stern and Gerlach, who did an experiment, and they found that just as Earth rotates about its axis, it can be either clockwise or it can be anti-clockwise. So similarly, your electron also rotates either in one direction or the other. So these were named as spin. So it spins clockwise once and anti-clockwise the other time. So for each of the orbitals that you have, for each of the orbitals, you will have 2 spins associated with it. Okay, alright. So that is generally known as the spin quantum number. This is the spin quantum number, and this is a very important thing to note, that your spin quantum number is actually obtained from an experiment and not the solution of Schrödinger wave equation. And when you talk about the spin, here itself you can talk about a spin angular momentum. You can talk about a spin angular momentum, and that your spin angular momentum is equal to under root of s into s plus 1 into h upon 2 pi. under root of s into s plus 1, where s refers to the spin. Now your electron, the electron that you actually work with, you have been talking about throughout, has a spin which is equal to, it has a half integral spin. So you can calculate the spin angular momentum of an electron. This question is also asked many a times. Calculate the spin angular momentum of an electron, or which is the spin angular momentum, and then you have 4 choices. That will be simply half into half plus 1, and you can easily calculate that. H upon 2 pi, that will be somewhere around root 3 by 2h cross. What is your h cross? H upon 2 pi. So remember that you have your spin angular momentum and you have your orbital angular momentum. Orbital angular momentum is dependent upon your quantum number L. Spin angular momentum is dependent upon your quantum number S. And the spin associated within, and generally the spin associated with an electron, for an electron the spin associated has 2 spins. They are generally written as ms. So you have a plus half spin or you have a minus half. So plus half generally refers to the clockwise spinning and minus half refers to the anti-clockwise spinning. And each of the m values is associated with 2 spins of the electron. So you have is associated with 2 electrons here. So you will have plus half minus half. For each of these levels, now you have plus half minus half. Is it visible? It is plus half and minus half here. For each of the levels, we have a plus half and a minus half. Clear? So that ways for each of the levels. So you can even calculate the number of electrons, which are the total number of electrons which can be accommodated in a particular shell. The number of electrons that can be accommodated now for 1s will be only 2. For 2s, 2. For p, in all the cases it will be 6. And for why p is 6? Because 2 are associated with each of the orbitals. So 2, 4, 6. Okay? Clear to everyone? Now for d, when we represent, d will be 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay. So the 5 d orbitals. So each will have 2 electrons. So 2, 4, 6, 8, 10. So d can accommodate a maximum of 10 electrons. So if I am talking about the total number of electrons associated with n is equal to 3, then how can you find out? This will be simply, you will have 3s, 3p and 3d. So it will be 2 plus 6 plus 10. That is 18. That is 2 plus 6 plus 10. 18 electrons. That you can do? You all know this? The voices are fading away. So wake up. Now here what we have is, we have just talked about the spin angular momentum and the orbital angular momentum. Repeat the formula for orbital angular momentum, all of you. Under root of L into L plus 1 into h upon 2 pi or h cross. And for the spin angular momentum, under root of S into S plus 1 into h upon 2 pi. So all of you all awake now? And then how many, what are the 3 quantum numbers obtained from the solution of SWE? N, L, M. And what about the 4th quantum number? Experimentally and not from Schrödinger wave equation. It was developed by Stern and Gerlach by an experiment in which they found that there are 2 spins, either clockwise or anti-clockwise. Okay. Now you must have understood what is the difference between an orbit and an orbital, because we are talking about the probability now. So when we are talking about an orbit, orbit means it's like a fixed space around the nucleus. Orbit means fixed space. MVR is equal to NH upon 2 pi. Matlab, it will not move here, there from it. Whatever is the angular momentum, it will just stay there and just keep revolving in a particular orbit. But what is the concept of an orbital? It is a quantum mechanical concept. Abhi tak, hum Bohr tak, we were talking about orbit. Now we have started talking about orbitals. Orbital means that there is a probability of finding the electron in a region of space. So that means your electron can move about in a region of space. So it is not just a fixed orbit, but it's a kind of a spherical shell in which your electron is not just moving like this, but it's moving like this. Okay? It's not exactly, it's translating and moving. You get it? एक spherical shell है around the nucleus. Your electron is moving around the nucleus, so it's not just following one path. It's moving to and fro, but it's not vibration motion, it's translation because it's moving ahead. It's moving जैसे you have your nucleus here, you have your spherical shell say here, about this only. So your electron is moving like this. It's moving to, okay, and very close to one another. I have shown it at a distance. Like the electron is moving in that fashion because it's a zigzag. Yeah, you can say zigzag. So it's translating and moving. The point is that the electron is not just executing electronic motion. There are two motions. One is electronic motion and the other is a translatory motion. You can understand? Electronic means moving around the nucleus in a circular path. And what is your translatory motion? That is like moving in within the spherical shell. So that's translation. Translation का मतलब होता है generally it's moving in one particular dimension. Got it? So that is what it talks about. So your orbital is generally characterized by N, L and M. What is the difference between orbit and an orbital? First, orbit is kind of a fixed. Orbital is a quantum mechanical concept and it has a probability associated with it. That this is the probability of the spherical shell. Then when we talk about another thing is like your orbit was just dependent upon N. What did Bohr talk about? Only one quantum number, that was N. First level, second level, third level and so on. But what did Schrödinger talk about? He did talk about N, L, M. S, P, D associated with each of these levels. And further on associated with M also. What does M do? Further subshell, it divides your subshell further into degenerate orbitals. What were those orbitals? Px, Py, Pz. The difference between your spin quantum number and your orbital, that was spin angular momentum. The question has been put a little wrongly. The difference between spin quantum number and angular momentum quantum number I can explain. What is your spin quantum number? It's S. It has only two values, plus half and minus half. What is your angular momentum quantum number? That is your L. That is your angular momentum quantum number is your L. That talks about the orbital angular momentum. L as orbit. What is your angular momentum? Capital L, which is equal to under root of L into L plus 1. Now another question which is like a thoughtful question. Now because you started thinking about the electron as to how it moves. So I appreciate this question, that the electron will it always move in a zigzag manner when the electron is moving in a spherical shell. Okay, now supposedly I have a particular rope to walk on. So I will make sure that I am walking on that orbit, but if I have a space to walk on, I can walk here, I can walk there, I can walk like this, right? So what electrons does is, it has the probability of translating within that region while further moving on. So not exactly zigzag, you will not call it zigzag exactly, but it is like translating. So either I can walk, say this, if this is the space from which I can walk on. So either I will walk in this particular region or I can come here. So it will keep on translating also and it will keep on moving further also. Okay. Now we move ahead. We move ahead in which we talk about the orbits and orbitals. Orbit was a Bohr's concept, fixed one. Orbital is a quantum mechanical concept given by Schrödinger, dependent upon three quantum numbers N, L, M. And what are the orbitals that we talk about? S, Px, Py, Pz, dx, dxy, dyz, dzx, dx square minus y square and dz square. Again a doubt, what is the difference between the orbits and an orbital? Orbit is like fixed around the nucleus. This was a concept that was given by Bohr. Bohr stated that the angular momentum is quantized, वहाँ पे he introduced n. and this n was referring to first level, second level, third level. And when we talk about orbitals, we have started talking about orbitals after discussing quantum mechanics. So here when we talk about orbitals, they are referring to a region of space where there is a probability of finding. So it's totally a quantum mechanical concept, and it is dependent upon three quantum numbers n, l and m. इनकी totality से we get our orbitals. What were the orbitals that we get? We get one is s. Alright, that may be 1s, 2s, 3s, 4s. Another one is like p. P starts from 2 because 2 gets a value of L as 1. Getting somewhat? So we have the orbitals as px, py, pz. So these are called the orbitals, and each of the orbitals can be associated with a maximum of 2 electrons, whereas the principal quantum number n can be associated with so many electrons. The principal quantum number can be associated with so many electrons. Okay, then we talk about the shapes of the atomic orbitals, where we can generally talk about the shape of s, p and d. First of all, understand the shape. These shapes are also mathematically first obtained from the solution of Schrodinger wave equation. We get a mathematical expression. Okay, this is not to be done, so you can pay attention to this. So this is like a mathematical expression which we try to plot. Okay, when we plot it, we get the orientation as to how your S looks like. S looks like, when I plot it, it looks like a spherical shell. Basically, this is known as the dot population picture. When I draw a boundary, this is known as a boundary surface diagram. So this is like representing, this boundary surface diagram is representing my S shell. Then my P is like dumbbell shaped. So this is my P. D is a double dumbbell shaped. So you have, alright, and D has several shapes. Let me just first talk about the basic ones. S is spherically symmetrical. P is a dumbbell shaped, and D has a double dumbbell. 2 dumbbells. You know all dumbbells? Now S is like spherically symmetrical, so there is no nodal plane in it. I will just explain the nodal plane. Let me first talk about the P. The S is spherically symmetrical. You all understand that? That means it's present in all the 3 dimensions equally. When it is present in all the 3 dimensions equally, then it will be spherically symmetrical. Then being it a dumbbell shape means that you will have 3 dimensions. Consider x and y to be on the board, or x and z to be on the board, and let y be perpendicular to the plane of the board. ठीक है, x y बोर्ड के ऊपर ही हैं, एक ऐसे 90 degrees, and z is this. Sorry, x z on the plane of the board and y as I have represented perpendicular to the plane of the board. Did I confuse you? So when I talk about px, means it is oriented along the x direction. So my px will be along the x direction. So what is this representing? Representing px. It's a dumbbell shaped along x. So this is the representation for px. Then for py, now you tell me, this is x, this is y, this is z. All 3 directions are mutually perpendicular. So py will be just along your y. Okay, and your pz Okay. Now understand here, look up, you will find this in all the books anyways, will be given in your study material also. Look up here now. What does this region show? That means there is maximum probability of finding the electron in this particular region. When you see the p orbital, p electron having an electron means that electron will be existing in such kind of a dumbbell shaped structure. जिसमें maximum probability is at the ends of it, right? and the minimum probability is in the middle. The minimum probability is in the middle. Getting the point? This is giving the shape. What does the shape means? This shape is actually some representation of the probability density. What is the probability of finding the electron in this region? So the probability of finding the electron is maximum at the two extremes and it is least in the middle. Clear with that? So the point that I draw here represents kind of a node. What is a node? It is the probability where the probability of finding the electron is negligible. It is that point, node is that point where the probability of finding the electron is negligible, which is almost zero. Got it? What is node?
Where the probability of finding the electron is almost negligible.
Where the probability of finding the electron is negligible. So this kind of represents a node. But if you look carefully into Px, then Yz is a plane. Px is only, say you have, look onto your table, you have an x, you have a y and you have a z. Okay? Px is only about x, wherever you put your x. So Yz is a total plane which has no electrons. Yz is a total plane where the probability is negligible to find electrons because your x has the maximum probability in Px. Here with me, all of you?
Yes, ma'am.
Now I am saying you have three dimensions, x, y, z. P is dumbbell shaped, Px is along x. So Yz will have a negligible probability. So इस case में for Px what will be the nodal plane? It will be Yz plane. So how many nodal planes? One. प्लेन तो ऐसे बनेगा ना एक्स वाई का वाई जेड का, अकेले तो सिर्फ एक्सिस बनेगी, ठीक है. सो इट इज अ प्लेन. नो गुड, व्हेन यू पुट से समथिंग रॉन्ग आई गेट द फीलिंग दैट यू आर पेइंग अटेंशन. सो यू हैव द वाई जेड प्लेन विच इज द नोडल प्लेन. फॉर पी वाई इट विल बी द एक्स जेड प्लेन. Y is coming out of the plane, it's perpendicular plane of the board, and xz is your plane of the board in itself. So xz plane is the nodal plane, again one nodal plane, and for pz again also xy is the nodal plane. You should know which nodal plane and how many nodal planes, one for each of the p orbitals. Clear with that? All of you all? Okay, then we come on to dx. Now dxy, you have x, you have y and you have z. Alright, so again dxy means it's a double dumbbell, one dumbbell along x and the other dumbbell along y. So one dumbbell along x and the other dumbbell along y. Okay, just make it properly. I'll make dzx clearly. You have x here, you have z here, and you have y here. So here will you have any nodal plane?
No.
Will you have any nodal planes here in this case?
No, ma'am.
Okay, and then you can draw the d, xy done, zx done. What is left? Yz. You can draw the yz, means one dumbbell along y, the other dumbbell along z. Draw it on your own, and then I will just come to dx square minus y square. Dx square minus y square is like if this is your x direction and this is your y and z is mutually perpendicular, then your x square minus y square lies in the four quadrants. Okay? X square minus y square does not lie along the axis but this lies along the four quadrants. Then check it out for dz square. Dz square is like if this is x, this is your z, then dz square is along this and there is like a spherical shell, a small ring here. This is the shape that comes out from the dz square.
In dx square minus y square, why don't we have z?
You have the z axis. ये रही, ये देखो बोर्ड से बाहर निकल के आ रही है perpendicular. Who asked that question? देखिए, x is on the plane of the board, y is also on the plane of the board, and this pen is my z axis. Z is mutually perpendicular. So if you want to show, had I shown a z on the plane of the board, there may have been doubts in some students mind कि ये z के ऊपर से कैसे निकल रही है. So 2D representation for a 3D structure is like a little difficult. So z is like coming out of the plane of the board. You know that x, y and z are all three mutually perpendicular directions. Okay, hurry up. Done with this? Okay, now these were the shapes that came up from the Schrodinger wave equation solution. After that, we need to actually know, see, there is a shell, 1, 2, 3, 4 are the main principal shells. Then there are subshells like S, P, D. You call them subshells. Now then the orbitals of those subshells will be Px, Py, Pz, S, dxy, dyz, dzx, all these are like the subshell, the orbitals associated with the subshells. Got it? How can we name any subshell as dx, dy, dz, dx, dy, dxz? Please explain this concept again. See, xy, when n is equal to say 3 and when L is equal to 2, then what is the main orbital which is getting represented, the main shell which is getting represented? It's a 3, and you know it is, when L is 0 it's S, when L is 1 it's P, when L is 2 it's T, so it becomes 3D, right? Now then M is equal to minus 2, minus 1, 0, plus 1, plus 2. All these 5 orbitals associated with this subshell D are degenerate. Degenerate means energy, that the existence of same energy states, several energy states at the same energy level. That means right now if I put a line here and make you all sit on the same, so you can occupy any seat, because for you all are degenerate, provided you listen properly. Matlab, the energy associated with each of the orbitals is exactly the same at the same energy level. So existence of several energy states at the same energy level, which implies that the 5 orbitals of D which are there, dxy, I shouldn't be writing it here, that's the space for the electrons, dxy, dyz, dzx, dx square minus y square, dz square, all of them have the same energy. So there is like equal probability of each one of them to be existing and getting occupied by the first electron. Degeneracy matlab they have all the same energy, so that is why irrespective of which value you give to one. Otherwise quantum mechanically you get a specific expression. We have done the shapes. So S is spherically symmetrical, P is dumbbell shaped, and D is double dumbbell shaped. Next we come on to an important principle, which is the Aufbau's principle. Okay, just note this principle down. It actually states that the various shells or of any particular element get filled according to the order of energy. That means the one which has lower energy will get filled first, and then the higher energies will get filled filled later. The lower energies will get filled first. This you must have done by a very famous diagram also. I repeat the Aufbau's principle. It states that the electrons are added progressively to various orbitals. Various orbitals means the orbitals that you have. You can say that D are also orbitals, and D has how many orbitals within it? 5. P is also an orbital, but how many orbitals within it? हम सिर्फ सबशेल इसलिए बोलते हैं because we have a main shell which is divided into further subshells like S, P, D. So we call it subshells. Alright. So I repeat, the Aufbau's principle states that the electrons are added progressively to different orbitals according to their increasing order of energy. So in this it is like a very simple diagram. What you do is you just write 1s, 2s, 3s, 3p, 3s, 4s. You write all the s's in one particular go. Okay. Then you know that only 2 is associated with p. Why? Because when n is equal to 2, L is equal to 1. Either to there is no possibility, no, because when n is equal to 1, then your L can be only equal to 0. Now when n is equal to 2, L will be equal to 0 and L will also be equal to 1. So you will have 2s 2p. फिर 2p के नीचे उसकी line चलाओ, 2p 3p, you will have 4p, you will have 5p, you can have more also. And then you know that there is no 2d. Why is there no 2d? Because when n is equal to 2, your L can be only equal to 0 and 1, but not 2. So for 3 you will have a 3d. So you start from here, 3d, 4d, 5d, 6d and so on. This is like how to make this diagram. You all must be knowing. And then you have 4f, 5f, 6f and so on. It's easy to make this diagram. I think all of you all will be able to make it. Then here, what you do is draw lines, carefully look at it, draw lines in a slanting manner in such a way that you have 1s, then you have 2s, then 2p will have the diagonal 3s about it, right? Then you will have 3p, 4s, then you will have 3d, 4p, 5s, 4d, 5p, 6s and so on. I am not drawing it further because you don't have to go to that extent. Clear? You all know how to make this diagram, you've done it in school before. So you make the slanting lines, I proceed and then you join them. Join the lower end with the higher end. Okay. So this kind of gives you the order of filling up. The order of filling up. That means 1s will get filled first, 2s followed by 2p, 3s, 3p, 4s. After 3p you will have 4s. After 4s you will have 3d, 4p, 5s. Clear with this particular concept? Then I will give you, remember that, turn this, yes? Finding the energy of the orbitals, yes, we can find out the energy of the orbitals depending upon what the value of n is. If you know n, then you can easily find out according to the expression of energy that we've done earlier. Okay, so now, and remember there is another principle. Along with Aufbau's, it is always advisable to do the Pauli's exclusion principle also. What is Pauli's exclusion principle? That not more than 2 electrons can be accommodated in a single orbital. That the maximum number of orbitals can, maximum number of electrons that can be accommodated in any orbital is 2. Another statement of Pauli is that no 2 electrons will ever have all the 4 quantum numbers the same. This is the second statement. We are talking about Pauli's exclusion principle. The first statement was that I stated that each of the orbitals can accommodate a maximum of 2 electrons. That means the boxes that I drawn like this. So that is why I stated S can accommodate a maximum of 2. P can accommodate a maximum of 6 because each orbital can accommodate a maximum of 2 electrons. Then the next is like, then D, how many electrons can D accommodate? 10. What about F? F will have 7. 1, 2, 3, 4, 5 and you have 7. So it will accommodate a maximum of 14 electrons. Okay, one thing that is to be kept in mind is that another thing is that when you talk about the 2 electrons, no 2 electrons will always have the 4 quantum numbers the same. No 2 electrons will always have. You expect both the electrons to be say in d 3d z square. Okay, then in that case for both of them n will be equal to 3, L will be equal to 2, 0, 1, 2, S, P, D. M will be equal to say 0 and 0, right? For dz square, like I told you that it corresponds to the 0. because D will have plus 2, plus 1, 0, minus 1, minus 2 as the values. So if I am saying Pauli's exclusion principle states that no two electrons can have all the 4 quantum numbers the same. So for the 2 electrons in 3dz square, they will have 3 quantum numbers the same. The fourth one will change. Why? Because one of them will be plus half and the other will be minus half. So no 2 electrons will ever have all the 4 quantum numbers the same. And then after that there is another principle, that is the Hund's rule of maximum multiplicity. This was SPDF. Okay. Hund's rule of maximum multiplicity. It states that if you have several degenerate states, then each orbital will be singly filled first and then pairing will start. Okay. Now say if I have to distribute toffees amongst you all of you all are equal for me. So I will not give extra right from the beginning itself. I will wait each one of you so that each one of you get one toffee, then I will start giving the spare ones. Got the point? So Hund's rule of maximum multiplicity states that each orbital will be singly filled first. Each of the degenerate orbitals will be singly filled first and then the pairing will start. You can look into the books for a better language of the Hund's rule of maximum multiplicity. What is that? That each of the orbitals will be singly filled first. So for example, if you have some configuration which has p only 3 in the p orbital, so how will they be filled? 1, 2 and 3. And if it was p4, so 1, 2, 3 and then you will have 4. Any configuration which shows your p as 1, 2, 3, 4 is very good. Okay, now I am giving you a question. Write down the electronic configuration of beryllium, sodium, beryllium, sodium, calcium, potassium. Write down the electronic configuration. You have the Aufbau's principle with you. Write down the electronic configuration of first one that I gave was beryllium. What is the atomic number? High heli B. How do you remember? Hydrogen, helium, lithium, beryllium. So it is 4. So it is 1s2, 2s2. आगे कुछ नहीं. Then you have, what was the next that I gave?
Sodium.
Sodium is 11. Sodium is 11. All of you all remember it?
Yes, ma'am.
11 will be what? 1s2, 2s2, 2p6, 3s1. I hope all of you all are referring to the Aufbau's table. Right? So you have 1s2, 3s2, 2p6, 3s1. Okay, then the next that I gave you was calcium. Sulfur, chlorine, argon, potassium, calcium is 20. And keep counting. It is 6 plus 2 plus 2. So 10 electrons taken care of plus 1, 11. So now for calcium it will be 1s2, 2s2, 3p6. What after 3p is 4s. So you will have 4s, 2 and 3d will be 0 only. So if you write it or you do not write it, it doesn't make any difference. One thing, there is another rule. एक तो Aufbau's principle आपने कराया ना for finding out which will get the preference first to get filled up. That's according to the order of energy. There is another rule, that is the n plus L rule. आपको n value पता है? n value कौन सी है? ये principal shell वाली. These are the principal shell values. So n, you know the L values also because you know S, P, D, what. So if you are confused between 4s and 3d, 4s and 3d, find out the value of 4s for this. So in this case what we have is 4 plus 0. So that is 4. Alright. And then in that case you have 3 plus 2. That is 5. So according to n plus L rule, whichever orbital has a lower value of n plus L will get filled first. N plus L rule. N value is the n value that you have done, the quantum number value. L is the azimuthal quantum number, 0, 1, 2, whatever value that you have. And how do you get up this value? This is the value from S. You know L is equal to 0 for S. L is equal to 1 for P. L is equal to 2 for D. So this value is for the L. This is the principal quantum number. For S ka L is 0. So it becomes total is 4. For 3D, N value is 3. L value is 2. So it becomes 5. So according to N plus L rule, whichever has a lower value of N plus L will get filled first. It will have lower energy. And then what have you done? What was the last example I gave you? Potassium. Potassium is 19. So this you know 1s2, 2s2, 2p6, alright, very good. You've done it. Now do it for nitrogen. Quickly. I am just giving you 5 seconds. Nitrogen is 7. 1s2, 2s2, 7. 7 total करो. S में maximum 2, S में maximum 2, P में maximum 3. So it will be 1s2, 2s2, 2p3. Do it for neon. 1s2, 2s2, 2p6. It shouldn't be taking time at all. Now here I want to state that the half-filled and fully filled orbitals are more stable than the others. Please make it a point to note it down that the half-filled and fully filled orbitals are more stable than the irregularly filled orbitals. Half-filled and fully filled orbitals . When n is equal to 4, there is a question that when n is equal to 4 and L is equal to 3, explain the orbital's name. You tell me what orbital is this? You have 4, n4 means it's 4, the main principal shell is 4, L remember is 0, 1, what can the values L take up after your n? It can take up from 0 to n minus 1. So 0, 1, 2 and 3. These can be the possible values of L. So here you are talking, this will be S, this will be P, this will be D and this will be F. So the name will be 4F. Ma'am, if we accommodate all the orbitals of D, then what does it say about that shell? Then if you have say a configuration of D10, then it is the most stable one. Let's take up the d orbitals now in which d is getting filled up. Are you done with neon? I will come to this answer. We are done with neon. Neon is 1s2, 2s2, 2p6. That was 10. So p3 is more stable than p4 or p2. All of you all here with me? Yes, p3 will be more stable than p2 and p4. I mean in comparison to the energies. And p6 is anytime more stable. It's a noble gas configuration where the outermost orbital is completely filled. So you know that here in this case it's also highly stable. When you take up further topics on periodic properties and your chemical bonding, this will be used. Remember, half filled and fully filled are more stable. Okay, now there is another configuration now that you need to know very importantly, and that is for the atomic numbers 21 to 30. You all remember it from 1 to 20. Now from 21 to 30, for all those of you who do not remember the elements, remember it right now and you will require it till the end of your 12th standard also, because in 12th you will be doing D block separately. So it is scandium, titanium. Many of you confused, many of you don't know. For all those of you who do not remember, can remember it here right now by the weird method that I am generally in the habit of giving. What is that? Skirtai Vakraman. So that you do not. Phi ko niku zn. Phi ko niku zn. Say, repeat it again. Skirtai Vakraman. Phi ko niku zn. Repeat it again. Skirtai Vakraman. Phi ko niku zn. Repeat, all of you. Skirtai Vakraman. We kar man ya nahi kar man, you have to do it. So please remember this, and you can even use it at home to your siblings. Right? Skirt I work raman, fico nico zn, and he or she will keep on googling it to find out what does it mean. So good for the other person also. So this starts from 21. So 21, 22, 23, 24, then you have 25, 26, 27, 28, 29 and 30. So now here, now that you know how to fill in the electronic orbitals with the according to Aufbau's, here you know that till 20 what was the configuration? It was 1s2, 2s2, 2p6, 10 taken care of, 3s2, 3p6, 18 done, 4s2, and generally 3d was 0 here. So you know that in this case till 20 this will remain, and beyond 20 it will now be 3d1, 3d2, 3d3, 3d4 and so on. So now the d orbital has started to get filled up. D orbital will start getting filled up now. 20 तक तो मैंने कर ही दिया है. So now I want a quick answer within 2 minutes because we are running short of time also. I want you to do the electronic configuration for say vanadium. I want you to do it for, I want only for, okay, till 3p6 it's just the same. I want you to just write down the electronic configuration because 3p6 तक तो सबका same है, don't waste time. So you write it only for 4s, 3d and whatever. So you do it for chromium, this, Mn and copper 30. I am giving you 5 elements. What are those? Vanadium, chromium, manganese, then you have copper and zinc. Do it quickly. Quickly means quickly. Okay, this will be 3d3, 4s2, 3d. I'll talk about it. Give me a chance. नहीं फर्क पड़ता है, कैसे भी नहीं लिख सकते. Just that somebody was discussing, you can write it in any way that you feel like. Remember that although 4s is getting filled first, but it still remains as the outermost orbital. So if an electron has to be lost, 4s से पहले निकलेगा, 3d से बाद में निकलेगा. You getting the point? Please remember this concept. Although according to Aufbau's principle, your 3d is getting filled up first, and 4s is getting filled first before 3d. But still when you have to actually give out an electron, it will go from the outermost shell which is 4s. So when you write down the electronic configuration, while writing you may be writing 4s first and 3d later. Right? All of you all must be doing that. You all are writing 4s and 3d later. But in the subjective examinations, you should always make it a point to write 3d first and 4s after that. Fill 4s first according to the Aufbau's rule, respect rule, and then respect the rule, and then after that do the actual thing which is like possible. Now if the electron has to be taken up, it will go out from 4s only. Now coming to the question that I asked you first. Vanadium is 3d3, 4s2. All of you all have it? Chromium 4s2 was already filled. So that is why I will write 4s2 outside to give it the actual look it looks like. And then you have 3d4. But now you know that half-filled orbitals are more stable. So in this case what it will do is, it will take one electron from 4s and it will become 3d5 4s1. A very common question. It was 24. 24 would have meant 4s2 3d4. And while writing properly, it would have been 3d4 4s2. But we know half-filled orbitals are more stable. What is our D? D can accommodate 10 electrons. So half-filled means 5 electrons. Now in order to have 5 electrons, because it will look for extra stability, it will take one electron from S and then finally it will become 3d5 and 4s1. Got it? Yes? In this case, no. Then you actually have to look at the conditions under which they are existing. Okay, it is not just that, we have to go a step beyond. Right now just consider that when we are comparing its stability, we'll be comparing it with the configurations which are around it. Around it in the sense, इसके अंदर 3D10 का तो possibility है ही नहीं, so there is no scope of talking about it. If I compare you with a third standard student, no significance. If I compare you with your classmate, a lot of classmates, a lot of significance. So we'll compare it according to that. Here 3D10 has no scope, so it will be 3D5 only and 4S1. I'll take it out. Then we have here 4D5 and 4S2. This is 3D5 and 4S2. This is the normal one. Normal case, no abnormal one. Then in copper now you know is 3D9. It will be 4S2 and 3D9. So it has again a chance. If copper can take, it can also take one electron. So what it will do, it will take that one electron from 4S, it will become 3D10 and 4S1. And then the last one, zinc. So zinc is actually fully filled. Manganese is also half filled in according to the normal atomic number. Here in this case you have Mn as 25. So that's like normal. In chromium and copper case, remember that one electron is taken from 4S and then extra stability is looked for. We got 3D5 in case of chromium and we got 3D10 in case of copper. Now do the electronic configuration for Fe2 plus and Fe3 plus. Remember 2 plus का मतलब 2 electrons दे देने हैं. पहले Fe लिखो, right, for Fe first. Do it. What will Fe be?
3D6 4S2.
It will be 3D6 4S2. So what will be Fe2 plus?
3D5 4S1.
It will be 3D5 4S. Huh? Shh. No. Wait. For Fe, what have you written? It is 3D6 4S2. So when the electrons are to be given 2 plus, फिर नहीं you have to do any kind of bias factor. You don't have to be partial कि इसको निकाल लेते हैं, half कर देते हैं या कुछ. We have to go about what happens actually in reality. It will be 3D6 4S2. 2 plus means 2 are to be given only from S now because it is located outside. If you have to start moving out, the ones who are just sitting here will move out first. So it is like 3D6 4S0. What about Fe3 plus? 3D5. No need to mention. Just 3D5. You write down the electronic configuration as 1s to 2s to 2p6, 3s to 3p6 and 3D5.
And if I say amplitude negative 2 minus, then
generally we refer to only those electronic configurations in which your element is existing more in the compound formation or the some kind of stable compound formation. Okay, then do it for V3 plus Br minus. Do it for Br minus and V3 plus. V3 plus means I am talking about vanadium. Niche scroll. V3 plus, vanadium 3 plus, you can do it. And then for after vanadium 3 plus, I am asking you to do it for Br minus. Do it for V3 plus. V3 plus will be 3D3 4S2. So 3 plus means it will be 3D2. After 2 electrons are given from S, 1 will be taken out from D. What about Br minus? The number is 35. Bromine, the number is 35. Just do it quickly. Just tell me the outermost configuration. It will be 3D10, 4S2, 4P, 4P. Wait, 4S, 3D, 4P. Minus Arey Baba, till 30 you had done. Till 30 all of you all had done. What was 30? I'll just put it down here. 4s2 and directly 3d 10. So 30 have been taken care of till here, right? Now how many more electrons? 5. I am saying that bromine atomic number is 35. So for 35, 30 have been taken care of. Now it's the chance of 4p now. Refer to your above table. 4p will have 5. Maximum electrons can be 6. So 5. Now do you have to give electron or gain an electron? Minus means it's taking. So it will be 4p. So don't be in a hurry. You all know the concept. So give, at least time is not there, some brains to give the right answer. Okay. Then which would be more reactive, Fe2 plus or Fe3 plus? Very good question. Now basically you tell me what is the configuration of Fe2 plus and 3 plus again?
Fe2 plus is 3d6.
This is 3d6 and this is
3d5.
3d5. तो कभी सुना है ferrous getting converted to ferric? Have you? No. You will be doing salt analysis most probably in next year in chemistry practicals only. Normally this Fe2 plus, which is more stable? 3d6, which is more stable?
3 plus.
So generally what happens is, even if Fe2 plus exists, it will try to give one more electron to get converted to Fe3 plus. This is known as ferrous and this is known as ferric. So basically it has a temptation to get converted from Fe2 plus to Fe3 plus by giving an electron, and out of these two you can easily make out which is more stable, right? Is reactivity of elements dependent upon stability? Yes. Yes is the answer. Why? Hund's rule is known as the rule of maximum multiplicity. The question is, why is Hund's rule known as the rule of maximum multiplicity? Because in this case multiplicity refers to under root of s into s plus 1. This is again a very good question, I would say. Today I am getting very good questions. Now what is maximum multiplicity? Multiplicity refers to s into s plus 1. That gives you the multiplicity. Okay. This was used for your spin angular momentum quantum number into under root of s into s plus 1 into h upon 2 pi. So when you have electrons, how many? 1, 2, 3. Hund's rule ke according each one will get singly filled first. So then in that case, मान लो each one has a plus half spin. Each one may have a plus half spin. So then in that case, what will be the total spin? It will be 3 by 2. It will be 3 by 2 and that will be 3 by 2 plus 1 if you can get it easily. Spin multiplicity can be noted down by a factor of s into s plus 1. So when you have all the three singly filled first, Hund's rule तो समझ में आ गया था that each one will be singly filled first and then pairing will start. अब मान लो if this was not the case, then in that case pairing will start first. If I am not following Hund's rule, then pairing will start first and then we'll have the third electron here. So what is the total spin in this case? Plus half, minus half, plus half. ये तो cancel हो गया. You will have only plus half. So where will the spin multiplicity be maximum? In case of where you have 3 electrons which are singly filled. Getting the point? So that is why there is no other possibility. So it was a very thoughtful question. Got the point? Spin multiplicity refers to, अच्छा एक और चीज यहाँ पे बताती हूँ. Whenever your element, you know how to write down the electronic configuration, all of you all. So you know that when you are writing 3d5, okay, you will write it as 1, 2, 3, 4, 5. Okay, just make it a point according to Hund's rule of maximum multiplicity. You will be writing it as 3d5. मान लो if it is a 3d8 system, that's cobalt. Cobalt is 3d7. This is nickel. Nickel will be 3d8 4s2, right? And Ni2 plus will be 3d8. So I am talking about which case? Ni2 plus. Ni2 plus will be 3d8. So that means 1, 2, 3, 4, 5 according to Hund's rule. 6, 7, 8. This will be how it will be filled. Writing में तो you write it as 3d8 ऊपर superscript बना के you write 8. But when you will actually see it in orbitals, it will look like that. Remember that whenever there are unpaired electrons in your system, that system will be paramagnetic in nature. Write it down. It's a very important thing that you will use for the next almost 2 years and more. Hopefully you all should be continuing with sciences. So what we have is, remember that whenever there are, and how will you get to know about the unpaired electrons? By filling up according to Hund's rule. Then only you will get to know which one will have unpaired electrons. Because pairing का तभी पता चलेगा ना, सिर्फ देख के 3d8 से नहीं पता चलेगा. 3d8 से आपको लगेगा 4 electrons ऐसे, 4 electrons ऐसे, you may do it wrongly. So remember that whenever you have to fill in the electrons in your 3D shell, they have to be singly filled first according to Hund's rule, and then follow the Pauli's exclusion principle, not more than 2 electrons. So you have 2, 4, 6 and 2 unpaired electrons. So remember that the magnetic character will exist even if there is a single unpaired electron. So magnetic character will be maximum in the ones in which have 5, like manganese had 3d5, right? Skertai Vakra 1. So please don't write it as Man, it's Mn. Adhere to the normal symbols. So Mn is 3d5, so it will have 5 unpaired electrons. That means the magnetic character will be really high. That is what is the next question all about. You can actually find out the magnetic character by a formula of under root of n into n plus 1. See the magnetic moment of any of these elements. This is mu is representing your magnetic moment. Okay, this magnetic moment mu is equal to under root of n into n plus 2. The units will be Bohr magneton, Bm, n into n plus 2, where n is the number of unpaired electrons. And you know that even if a single electron is unpaired, your system will be paramagnetic in nature. So if I ask you to calculate the magnetic character of manganese, find out. That will be under root of how many unpaired electrons? 5. So 5 into 5 plus 2. अभी तक 1 था, तो don't please remember it as 1. For the magnetic character, it is under root of n into n plus 2. Units are in Bohr magneton. And you have, say if you have 5 unpaired, so 5 into 7 root of 35. Keep calculating it later. It will be root of 35. Yes?
And what does the term paramagnetic
Paramagnetic
mean?
means, when you are bringing up a particular element in the magnetic field. ठीक है, मान लो यहाँ पे नॉर्थ पोल है, यहाँ पे साउथ पोल. मैग्नेट्स ऐसे ही होते हैं ना, कुछ करा है मैग्नेट्स का कभी फिजिक्स में? So you have a magnetic field. The moment you will get that element in the paramagnetic field, the moment you will get that element in the magnetic field, it will either get attracted or repelled by the field. If it is responding to the magnetic environment, it means it is paramagnetic in nature. And it will get magnetized till the time it is there in the magnetic field. The moment it steps out, it will be again the same. Okay? And if you have diamagnetic means, like for the case of neon, what was neon? 10, that was 1s2, 2s2 and 2p6. Let me just draw the last orbital only, p6. So 1, 2, 3, 4, 5 and 6. So in this case, how many unpaired electrons? 0. So in this case, there are, when you have totally not even a single unpaired electron, then in that case you say that your element is diamagnetic. And what do you understand by a diamagnetic substance? It is the one which will be repelled, which will actually be just remaining as demagnetized only. You say that the magnetic behavior for that is 0. And paramagnetic substances are the ones which possess magnetism. And what is the magnetism for the elements? You can easily find out, because now you know how to do the electronic configuration. That is under root of n into n plus 2. Clear to everyone? And then we just have questions to practice. So I can pass you on the questions to all of you all, and you can practice these questions if your concepts are clear, right? And if in case you have any doubts, you can talk to the coordinators. Ma'ams are here to help you, and please leave the doubts, because this is like a lengthy but an easy topic, and the first time that you're doing quantum mechanics, so please make sure that you do it really very well for a better understanding of chemistry in future, right? Thank you.